Welcome back to part 2 of our introduction to lists. So in the last session we learned about the general structure of lists and how to create lists. So now in this session we learn how to select single and multiple elements from a list and how to manipulate and change elements of a list. And we also learn how to slice lists and make subselection of lists. But now let's start with our list L, which we already know. And our first task is we want to select the very first element of this list. And the general rule is that elements of a list can be accessed with spare brackets. So we take L, spare bracket, and let's try to get the very first element of the list. So we type in 1 and let's see what we get. So we get 2. So 2 is actually the second element. So how do we get now our first element? And the answer is actually that we have to type in 0 as index, and let's see what we get. So if we type in 0, we get the first element here, it's 1. And this is neither a mistake or a special or strange behavior of Python. Yeah, it's a commonly seen pattern in programming or coding that you have the so-called zero-based indexing. So the very first element of a sequence has the index position 0. And then the second has the index position 1. The third element has the index position 2, and so on. Yeah, and this is a general rule in many programming languages. So once again, it's called zero-based indexing. Alright, so what if now we want to get the fifth element of our list? So the fifth element is 5. So consequently, we have to input the index position 4. And now it should return us 5. And this is true. Alternatively, we can also assess the very last element of a sequence by typing the index position -1. So -1 gets us the very last element of a sequence. So in this case, it's 5. And the second very last element of our list can be assessed by the index position -2. And consequently, the first element of our list can also be indexed by -5. So there are two ways to index our lists. So there's the zero-based indexing starting from 0. So our element 1 has index position 0, index position 1, index position 2, index position 4, index position 3 and index position 4. And the alternative way would be to have index position -1, index position -2, index position -3, index position -4 and index position -5. So, and this holds true for almost every kind of sequence, so not only for lists but also for tuples, which we see later, or for NumPy arrays and so on. So this is a very important and basic rule here, how to assess elements of a sequence. And what you can also do, you can do it the other way around. So you can, for a given element, let's say 5, Python can give you the index position. So, and you need the method index, and let's type in 5. So we would expect the 5 is at index position 4. So we would expect here to return 4. And that's correct. Lists are generally mutable. So what does it mean, mutable? So you can change elements of a list. And how do we do this? So we first have to select our element. Here we want to select the very first element at index position 0, and then we assign with the equal sign a new value. Here it's 100. So let's see what we get. And here you can see now our list, the first element is 100 and not 1. So we simply changed the first element at index position 0. And we can also change the very last element in our sequence. So L at index position -1 equals 101. Let's see if it works. And yes, it works. Now what if we want to select many elements of a list? And yeah, we can do this with so-called slicing by using a colon inside the spare brackets. So in this example here, we have a slice from the second element at index position 1, and by definition this element is including, so from first position until the fourth index position, but here excluding. So let's see what happens. So we have 2, 3 and 4. So we are slicing the list from index position 1 including until index position 4 excluding. So let's check again here. Let's see at the list. So here is index position 1 including until index position 4 but excluding. So we get 2, 3 and 4. And we can also slice from index position 1 to index position 5. So here in our list there's no index position 5. So by default we get all elements from index position 1 until the very end. So let's check. And we get 2, 3, 4 and yeah, here 101. And the alternative way to slice until the very last element, including the last element, is to have just one colon and then nothing. So this means we are slicing from 1 until the very last element, including the last element. And we can also slice from our very first element, so at index position 0 to, let's say, index position 3 excluding. Let's see what we get. So 100, 2 and 3. We have including the very first element until index position 3, so 0, 1, 2, 3, but excluding, so 100, 2 and 3. And the alternative way to do this, so slicing from the very first element to, let's say, the element at index position 3, is to have just here nothing colon 3. So this is the same actually. So in one more example, so let's slice from index position 1 including to index position 3 excluding, and we get 2 and 3. And we can also select all elements by just having a colon and on the left side of the colon and on the right side of the colon nothing. Gives us the whole list. Alright, so let's enlarge our list with some more elements, so from 1 to 10. And what we can also do, we can choose every second element of our list, and we can do this by having 2 colons. This gives us here every second element beginning from the first including. So we have here starting from the very first element, every second element. So 1, 3, 5, 7 and 9. And we can also select every third element beginning from the first element by having double colon and then every 3. So we are starting from the first element and then selecting every third element. So we have 1, 4, 7 and 10. And we can also start with, for example, the second element at index position 1 and then select every second element by defining here, okay, let's start from the second element at index position 1, but please only give me every second element. So we get 2, 4, 6, 8 and 10. So we are starting from the second element and then slicing every second element. So we have 2, 4, 6, 8 and 10. So let's start again with L, with our list, so from 1 to 10. And we can also assign many new values to many elements. So for example, if I want to assign to the element at index position 4, 50, and to the element at index position 5, 51, and to the element at index position 6, 52. I can do this by slicing L and assigning the new values which are here in a list. So, and as you can see here, we have at index position 4, so 0, 1, 2, 3, 4, we have 50, 51 at index position 5, and 52 at index position 6. Alright, so what we cannot do is the so-called broadcasting. So if we want to have at index position 4, 5, and 6, if we want to have 50, then our code as we have it here is not working. So we get an error message, and alternatively, we have to assign to index position 4, 50, 5, 50, and 6, 50. So we have to do it manually. And there we have 50 at index position 4, 5, and 6. Alternatively, we could have created a list of 3 times 50. So that's an alternative here. And what we can also do, we can delete an element at a certain index position. So let's say we want to delete the very first element at index position 0. We can do this. And as you can see here, the first element, so 1, is removed. Another thing I want to show you is a nested list or list of lists. So in the last session we learned that we can actually put any data type into a list, and this holds also true for a list itself. So you can just put one or many lists into a list. And for example, we have here a list of, let's say, football players. So in each football player has a name. Andy, for example, has a height 1.86 meters and has a weight, so 82 kilograms. And we have 4 players in our list, and for each player we have one list with the name, length, and the height. So we can create the list, and there we have the list so it's a nested list with 4 elements, and each element is a list itself. And we can also print the type and the length of the list. Let's do this. So we have, of course, this is a list, and it has 4 elements. And we can also slice or select elements of our list. So we can select the very first element at index position 0. So I would expect to get Andy here. Exactly. So we have Andy here. He is 1.86 meters tall and he has 82 kilograms. We can also get the very last player at index position 3 or -1, as you like. So we get Mike. So now what we can also do, we can select the height of the very first player. So let's say Andy. And we can do that by, first of all, select Andy. So now we have a sub-selection. We have here the sub-list, and then we want to select the second element at the index position 1. We can do this. And so we have selected the height of Andy, so it's 1.86 meters. And what we can also do, we can create a list containing only all 4 names of our players. So we create a list called names. We open the square brackets, and then we say, okay, the first element should be the very first player and the first element. So at index position 0, it's the name. Here it's Andy. And then give us the name of the second player. Give us the name of the third player and the name of the fourth player. So now we have a list containing only the names of our players. So we have a list of 4 strings. And there's another thing I want to show you here. Let's create a list X with 4 elements. And then we create another variable Y, and we assign X. So here Y was referenced to the same list. And now if we change the very first element of X, let's say X at index position 0 is 100. So now the list of X is 100, 2, 3, 4. And now if we are checking again our Y, so Y has also changed. So why is this the case? Well, and what Python does internally, here it creates a list object and references or makes a reference to variable X. And here we are assigning Y to X. So we are creating a reference from X to the same list object. So we only have one list object and we have 2 references. So one reference to X and one reference to Y. And now if we change our object by changing the first element of x, y references to the changed object. So maybe it was our intention that also y changed, but what if it's not our intention that y changes if x changes? And yeah, what we can do here is that we say, so let's start again here with x equals 1, 2, 3, 4, and then we create a copy here of the list by saying, okay, please create me a copy of x and assign it to y. So now y is referencing to a copy of x, so not to here the object itself. So now we created two objects. So we have one object, the original one, that is referencing to x, or x is referencing to the object, and we have a second object which has actually the same elements, but only y is referencing to the copied new object. And if we change here x now, so y does not change. And there's another way to do this. So let's start again. So we are creating an object 1, 2, 3, 4 and assigning x. So we can also create a copy of x by saying, okay, please give me all elements of x. So by writing it here in this manner, we are also creating a copy. So y is now referencing to a copy. So we have two objects, object 1 referencing to x, and object 2 where only y is referencing to it. And now if you change x, also there's no change with y. So we have two alternative solutions where we prevent that also y is changed if we change x. Alright, so at the beginning of this session here I said that elements of sequences can be assessed with square brackets, and this not only holds for lists but also for other sequences or other data types which are sequences like strings. So if we create a string dog is a sequence of 3 characters, D-O-G, and we can also select here the first element at index position 0. So it's D. And we can also select the very last element, G. And before we said that lists are mutable, so we can change elements in a list. And that's the difference to strings. So strings are immutable. If we want to assign a new value to, let's say, index position 1, let's say A, so dag instead of dog, then Python gives us an error message. So this is an example that string objects are, or as a sequence that is immutable. Alright, so now we have finished our session here, and I hope you have a better understanding of lists. And in our next session we are going to the next data type, which is also a sequence, tuples. So hope to see you in the next session. Bye.